Okay, good morning. We are going to explain, we are going to study about the programming 8085. But yeah, I need to create this session because we are going to discuss about the macro. Before we continue about the macro, I'd like to wrap up the previous session, but in simply way. So then you can follow the current of the situation. So then maybe you can tune in the macro. Uh, so we can discuss about the macro definedly. Okay. Yeah. Somehow I know that some of you forget one or two about the fundamental of the programming language. So then I'd like to, just take a back for a moment to understand the programming language of 8085. Okay, so programming the 8085, we have at carry. This is the opcode, this is the operand. So then you do the addition, and then with the carry here to be added as a third party. Yeah, this is first party, this is second party, this is third party. Okay, and then you have three variables here that you need to do the summation, and then the result will be stored in the accumulator, of course. So this is the immediate program. So the opcode is the data. Sorry, the operand is the data, right? Not register. Yeah. And then this is the register as operand. It is the same as the previous session. So we have three parties here. So carry as a third party, and don't forget to analyze the, what is it? What we call here flex, yeah, flex registers. Yeah. So the maybe the question of some of you is actually, uh, what is the purpose of flex flex register? The purpose of flex register to uh, give the information what happened in the instruction. For example, does instruction has zero result? So if it does, then the flex will be high or one. Does it has odd parity? So if it is, then the parity flag will be high, and so on and so forth. Yeah, and then for example of the simple program. This is, we already know about the concept of add. So you do the add here, and then the result will be stored in the register A. So we call it as a mnemoic. Yeah. Okay. We are not going to explain this one in the deep, because we already told you, because I already told you in the previous lesson. So remember that assembly program language program will be brought into the assembly process, and then the assembly process will decode your program to the binary machine language code. Okay. This is the programming model of 8085. Please remember that it has a 16-bit address bus, 8-bit data bus, and then control bus. Don't forget the control bus is bus that in that medium, bus is actually medium, has the controller instruction. Okay. For example, control bus to control the additional memory. Okay. And then the bus will be control another thing such as timing. Timing means that you, what is it? You do the instruction, and then when the instruction being processed, it is the job of the timing. And then this is the accumulator. So this is the flag register that being active because of the accumulator. So we have 6 general purpose register B, C, D, E, H, L. Yeah, and then we have an accumulator. So this register is part of LU. This is 8-bit data storage, perform arithmetic and logical operation, and then usually it is stored the result of the logical operation. Okay, we have a flag register that I already told you in previous session. We have zero flag, carry flag, sign flag, parity flag, auxiliary flag. So these flags are flip-flop in the flag registers. Execution and of an arithmetic or logical operation can be set or reset by these flags. Condition flag is of course set and reset because it is a register flip-flop. Can be tested through the software instruction. So 8085 use this flag in decision-making process. As I told you previously, this flags denotes the information about what happened in the instruction. So we have a program counter. So 16-bit memory pointer, program wide, used to sequence program about the execution, the program instruction. Yeah, it means sequence. Yeah, sequence meaning that which in the program that instruction need to be processed. It is the job of the program counter that as a pointer to point address which the instruction inside the address to be processed. So this is the stack pointer registers, 16-bit memory, point location the stack memory. So beginning of the stack is defined by loading 16-bit address in the stack pointer registers. Okay, we have instruction set, for example, consists of 74 operation codes, example of move, LTI, and so on and so forth. Instruction code, move AP, and so on and so forth. 8085 instruction can be classified data transfer, arithmetic, logical bit manipulation, branch, and machine control. For example, data transfer, load 8-bit memory to register, load 8-bit number in the register, copy from register, copy between register and memory, copy between input output port and accumulator, load a 16-bit numbers in the register pair, copy between register pair and the stack memory. So for example, example data transfer, for example. So we have operation here, we have instruction. So the operation meaning that load 8-bit number for F hexa in the register B. We do the MVIB, comma for F hexa and then copy from register B to register A because it is already in the register B. So you need to copy in order to have accumulator store the register. Okay, and then load register 2050 hexa. Yeah, for the register pair HL. Yeah, you need to simply type H. Yeah, then copy register B to memory address 2050 here, and then copy between input output port. You can do the out 1 hexa in 7 hexa. Okay. So arithmetic operation, addition, subtraction, increment, and decrement. So how about the multiplication? How about the division? You can do the multiplication by using the addition. You can do the division by using the subtraction. It is. For example, add it 32 to the accumulator. So you can do the ADI 32 hexa. Okay. Accumulator is automatically being added by 32 hexa, and then the result will be stored, of course, in accumulator. Number two, add content register B to accumulator. You can do the add B, subtract 8-bit number 32 hexa from accumulator. You can do the SUI 32 hexa, and then subtract content of register C from accumulator. You can do the sub C in the instruction. Increment by one of register T, you do the E and R, I and R, D. Decrement is D, C, R, E. Okay. About the logical and bit manipulation, you do the uh, logical gate, yeah, and or exclusive or compare, complement, rotate, left, right, and so on and so forth. For example, rotate number 6, yeah, rotate accumulator to left, then you do the rotation, RAL. So you do the rotation, the accumulator, content of the accumulator being rotated into left. Complement, you simple saying that CMA, then the program will automatically complement what is inside in the accumulator. So branching operation, we have jump, we have call and returns. So for example, the branching operation, we do the jump to the 16-bit address 2018 hexa if the carry set, yeah, then due to the jump, for example, if the carry flag is set, and then you do the jump. Okay, how do I do that? You just simply saying GC 2080 hexa. Okay, when the addition resulted carry flag is active, then you automatically, if GC is being written, then it is automatically jump to location that already being pointed by the GC, which is 2080. Unconditional jump, then you do the GMP, this one, okay, 2050. You can call subroutine for the 16-bit address, then you can call this one. So please remember that your program should be on the location itself, the first location. For example, you want to jump in location 2000. It means that your first program should be on the 2000. It is. And then you do the return back from the call. You just simply typing read, yeah, and then you can call the subroutine with its 16-bit. If carry flag is reset, then you do the CNC 3050 hexa, for example. You can return if zero flag is set, you do the RC instruction. So about the machine control instruction, you do you able to halt or able to stop the instruction by typing HLT and NOP. HLT meaning that you stop the program execution, and OP meaning that you do not perform any operation at all. So writing assembly program, this is the tips that you need to follow. First is analyze the program. Second is develop the program logic. Third is write the algorithm. And then in order to make sure that algorithm is right, you create a flowchart. Write program instruction is using the assembly 8085. For example, how to analyze the program. What program do you want to create? For example, addition to 8-bit program to be done. This is about how to analyze the program. Yeah. You need to know what your expectation in order to create that program. Program logic, add the numbers and then store the result in register C, for example, following thing. Okay. For example, get to numbers. For example, load first number into register D, sorry. Load second number to register E and then add them and then store the result. Yeah, because the result is automatically stored in the accumulator. And then after that, if you want to store in the register C, move the accumulator to register C. Do the halt or stop the program. So after you already knew about the logic behind the process, and then you create the flowchart, make the flowchart. First is load register TE, and then after that, so this is the yellow one is load register D and load register E by data. Data is 2 hexa and 3 hexa. And then after that, add them. You do the summation, the binary summation or binary addition. Uh, this one, yeah. Move D to A and then add E. And then after that, copy or move content in the register A to register C. And then stop. So result of the addition to bit numbers can be uh, what is it? Can be processed by the following. Example, you have the register content of 99 hexa and then register content B is 99 hexa. And then you do the addition and then the result is 132 hexa. The 8-bit is being called as a carry bit. So if it is happen, meaning that carry bit is active. How does it? So this is the result. This is the result. Okay. Yeah. This one being added by this one. So this is the result. So the result being put into register and then yeah is going to register C. The algorithm will be load register T, copy T to A, add register E to C, copy A to register C, use conditional jump instruction, clear register, increment, and then stop processing. This is the explanation. After the addition uh, already resulted, and then store 8-bit result to C, check carry flag. Yeah, if carry flag is set, use jump instruction, store carry flag in register B. Use jump instruction if the carry flag is set, clear register B, increment register B. Okay, using B as a what is it? As a victim check inside the jump instruction, then B being incremented, it is same as there is a carry flag, and then you put the carry flag in the register B. Processing, this is the flowchart. If carry not set, and then you do the stop. If carry set, if carry, then this is the assembly language. Jump instruction, jump if move A to C, jump if the carry set is set, U goes to N, right? N is actually the stop. If it is set, then you do the increment B. Okay, and then after that, addressing mode of 8085. This is uh, the topic that we already set in the test. Yeah. Very value of operand itself. The operand is the memory location. So memory tracing has two types. Okay, emulator with the memory with address 2050. You do the store, yeah, store E with the content of memory location with the address 3050. This is direct addressing. In direct addressing, for example, using the memory pointer register is using the memory pointer register to point the address of the memory location. For example, move M, A, copy register A to memory location whose address is stored in the register P pair HL, which is denoted as a M, as a M symbol, M register. Okay, so for example, M is denoted 2050. Okay, so then the data that inside in the register A 30 hexa should be copied to the 2050 address. Okay, this is the input output register. For example, uh, you want to input to the accumulator 7 hexa, and then you want to output to the, for example, the output session 21 hexa. So in 8085, instruction can be classified according to the size in bytes. There are three type of instructions, which is 1-byte instructions, 2-byte instruction, and 3-byte instructions. This is 1-byte instructions. Move CA at B halt is 1-byte instruction. Okay. 2-byte instruction MVI 32 A, 32 hexa. So MVI is binary code. The binary code of MVI is 0011, yeah, and 1110. And then 32 is 0011 0010. Okay. First byte specified the operation code. The second byte specifies the operand. It is the 2-byte instructions. 3-byte instruction, first byte specify the operation code, second and third byte specify the operand. For example, LXI is 2050. First byte is specified the operation code with this 21st hexa is same as mnemonic LXI. Okay, instruction and the binary code of this instruction. 2050 will be coded into second and third byte specifies of operand. 50 is the first byte as a LSB, less significant bit, or lower nibble, and the higher nibble is 20 hexa, which is stored in the third operand. Okay. For example, you want to separate the digits of hexadecimal number and store it into two different locations. This is the example. You load 2200 hexa, and then you put the lower nibble. Sorry, you put the higher nibble by masking the lower nibble. Okay. For example, the data that being added is the 45 hexa. Okay. So 0100 is being preserved, and then the other nibble will be put into 0. So the idea is how to make this higher nibble go to the lower nibble. The answer is using the rotation right. Okay, after you do the rotation right 4 times, then you have the 0100. And then after that, store the data, which is 4, yeah, higher nibble 4 into 2300. Okay, load the data again from 2200. Yeah, load data accumulator that being pointed by address 2200 hexa. And then after that, you get the lower nibble by masking the higher nibble. And then you do after you already have the lower nibble, then store the result to the location that being denoted by yourself. Yeah, 2301. So then we have able to spirit higher nibble and lower nibble, and then store them to the spirit memory locations. This is the block data transfer. Yeah, MVI, LXI, LXI. Yeah, this is the block data transfer. Okay. This is the continuation. Okay, we are talking about macros. Okay, you find that many instruction sequence are repeated with only certain parameter change. So macro is just like a function that enables you to call several times in order to prevent carrying to create a new. Because what? Because repetition is actually uh, make your memory inefficient. Okay, inefficient, meaning that you do the waste thing. Okay, so in order to prevent inefficient memory and then make your memory getting bigger and bigger inefficiently, then you create something that able to being called repeatedly. Meanwhile, your memory is efficient being used. Okay, how do we do that? We using macros as a we call it as a function. Okay, Writing repetitively, only changing the input variables. This is the idea behind the macros. Yeah, the most beneficial way to reducing the debugging time. Effort in duplication is, of course, reduced significantly. Okay, macro is routine in the formal sequence of prototype instructions. When it be called within program, result replacement of such call with code expansion consisting of the actual instruction represented. This is the concept of macro. I have CNFIRM confirm, which is the macros name. So I have to create macros, and then that macro that I've been created, I named it as a CN firm confirm. So the program inside the macro has to sentence. So the idea is how I concatenate two sentence to become whole sentence. The first sentence, a flight welcome you as a passenger. The second sentence, your flight number being stored in the variable f and o, uppercase, leaves d time, uppercase, and arrived in the test, uppercase, at time, uppercase. What I said uppercase here is the variable that need to be replaced by new value. This is the idea of macros. Remember that macros is actually the function, just like in C, in order to overcome the repetition, unnecessary repetition that being able to make your memory inefficient. Okay, for example, this above uppercase word being replaced by actual flight, F&O, departure time, T time, destination test, and arrival time, A time. So if you want to fill the confirm, then you just simply saying confirm 1, 2, 3. This one represent the first what is it? The first bracket F and then second bracket T time. It is the second session here, and then third bracket test. It is the third session, and so on and so forth. Yeah. So the result will be a flight welcome you as a passenger. Your flight number 1, 2, 3 leaves 10:45 and arrive in Jakarta at 11:45. So remember that macro able to make the repetition will be efficiently by changing the value inside the macro. So what is the difference between subroutine? One distinction between the two is the subroutine necessarily branches to another part of your program, while macro generate inline code. So it means that subroutine necessarily, yeah, it is necessary, it is a must to branch another part of the program. But in macro cannot. In macro, it is not do the branch things. It is generate inline code. So using macro, you able to save branching activity, which is make your memory wider, getting wider and wider. This is the idea. So it is usually the obtain similar result. Yes, of course, because you can do the branching activity using the normal call and return, right? But in macro, you simply saying you create a function and then you call the macro without worrying about the branching activity. Macro can contain subroutine and subroutine can contain macros. So using macro, this is the assemble instruction of using macros. Macro directive, NM, this is N directive, local directive, rep directive, and so on and so forth. Macro must be defined on the program first. Okay. Macro definition will be terminated by N M directive. So the prototype instruction bounded by macro and M directive. Directive or instruction are called the macro body. When label symbol used in the macro body have global scope, multiply defined symbol error result if macro is called more than once. A label can be given limited scope using local directive. This directive assigns as a unique value to the symbol each time the macro is being called and expanded. Dummy parameters also have limited scope. Occasionally, you may wish to duplicate block of code several times, either within a macro or in line with the other source code. This can be accomplished with minimal coding effort using REPT and IREPT and IRPC Directive. So, like a macro directive, these directives are terminated by an M. Exit M directive provide alternate exit from macro. So this is the macro definition. You have label name, macro, and then operand. Okay. For example, if you code ABC as a dummy parameter, the substitution will occur properly. However, you cannot use the accumulator or the B and C register within the macro because of the limited scope of dummy parameters. The use of these registers is not affected outside the macro definition. So, any machine instruction or applicable assembler directive can be included in the macro body. The distinguishing feature of macro prototype test is that part of it can be made variable by placing substitutable dummy parameters in the instruction file. So the dummy parameters are the same as the symbol in the operand file of the macro directive. For example, define macro mac1 with the dummy parameters g1, g2, and g3. So the following macro definition contain potential error. Okay, that will be clarified this potential error in the next session. So for example, you have macro, and then you have dummy parameter G1, G2, G3, and then you do the body, the instruction in the body of macro. Uh, LHLD. What is LHLD? LHLD is mnemonic stand for load HL pair using direct addressing memory location whose 16-bit address is denoted as 16. So the previous content HL register pair will be updated with new 16-bit value. SHL pair has to be updated, so the data comes from two consecutive memory locations starting with the address A16 and also the next address location. This instruction use absolute addressing mode for specifying the data in the instruction. And of course, LHLD occupies 3 bytes in the memory. Okay. And then after I load the G1 to the memory, and then I move the content inside the memory of G1 to accumulator. G2 to accumulator B, G3 is accumulator C. This is the end directive of the macro. As I told you in previous slide, this macro have potential error. So we need to overcome this error. But right now, we are not going to express this kind of error, but I want to take a note how to create the macro body. So by using local directive, we can overcome the previous error. Okay, how to overcome it? Very simple. You define the move as the local variable. If it is not being defined first by variable, then your program will be stuck. Yeah, because the move function will not able to be called in the next, what is it, next repetition. It is okay. This is the repetition directive or repetition instruction. Just like for, you try to repeat 6, yeah, and then rotate right, yeah, the 6, yeah, repeat. I mean, you do the repetition 6 times about the rotate right, yeah, and m, yeah, of course, and macro. This is the example rotate. This is the code of the macro. HLT, blah 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 blah, and then you do the repetition 5 times, and then and macro. Okay, this is the repetition. So and move MA, yeah, increment H, move MA, increment H, move NA, increment H 5 times. This is the analog code, yeah, analog instruction. This is the program code that using rep. This is program code without using rep that has similar value. This is IRPC Directive, yeah, indefinite indefinite repeat directive must contain one macro dummy. This is definite repeat. This is indefinite repeat. So how do you create it? This is indefinite repeat. The following code sequence gather byte the data from different memory location and then store them to the consecutive bytes beginning at the start of store it. So this is store it is the address, and then to indefinite repeat FLT, this is the variable. So you do the load FLT and then move to MA and then increment H. Okay, then load this one, move this one, move this one. This is indefinite repeat. So the definite repeat here being what is it? Being explained by this instruction. Okay, 1, 2, 3. So you do the 3 repetition. This is indefinite repeat characters directive using cause the sequence of the micro prototype instruction to be repeated for each text character of the actual parameter specified. If the text string is enclosed in the optional angel bracket, any delimiters appear in the text string are treated simply as text to be substituted into the prototype code. This is for an example. 1977. Okay, this is the generate coding. Load the date 1 and then increment X, move the memory location of X, then move the memory location of 9, move the memory location of 7, move the memory location of 7, and then halt, yeah, and macro. Exit M directive, meaning that you do the exit, just like halt. So this is the special macro operator. You have a and yeah, and characters is used to concatenate the link text and dummy parameters. Angel bracket used to delimit the text. Semicolon, double semicolon is used to prevent inclusion of the comment and expansion of the macro and reduce the storage requirement. Escape characters exclamation point or escape characters placed by before the character, usually as a delimiter to be passed as a literalized text in actual parameters. Null is to indicate the omission of the parameters. This is the nested macro definition. This is micro calls. You just simply call the micro. This is the load macro, and then this is the macro, yeah, G1, G2, G3. You do the load here as a macro call. Okay, we have a macro expansion. When macro is be called, then actual parameter is to be substituted into prototype code that can be passed in one of the nodes. Normally, the substitution of actual parameters for dummy parameters is simply a text substitution. The parameters are not being evaluated until the macro is expanded. For example, still on macro, here, this is, I already told you, this is the macro directive, macro body, and directive. Okay, this all the macro subject. I hope you can enjoy this subject. Thank you for your attention, and Tuhan Yesus memberkati.